In this video we're going to look at solution methods for first order differential equations. Our first solution method is for separable differential equations, and these are some examples taken from the textbook. We're going to look at the second of these. We've got dy dx equals e to the minus y multiplied by 3x minus 1 with the first order condition y of 0 equals 0. Now, as we see here, our first stage is to separate the y's and the x's. So we have e to the power y dy equals 3x minus 1 dx. Now we integrate both sides of this equation, and this will give us the following. The integral of e to the y is just e to the y, so we've got e to the y equals 3x squared divided by 2 minus x plus a constant term c. Now take logs of both sides of this equation and we get y equals log of 3x squared over 2 minus x plus c. We now use our first order condition to eliminate the constant of integration. So we have 0 equals log of 3x squared over 2 minus x plus c is equal to log of c, so therefore c equals 1. Therefore a solution here is y as a function of x is equal to the log of 3x squared over 2 minus x plus 1. Now, a particular form of differential equation that comes up a lot is a linear differential equation, and there's a rather easier solution method. So again, here are some examples taken from the textbook. We're going to look at example C here. We've got 4 dy dx plus 2y equals 6. Now we're first of all just going to write it in a standard form. We write it as dy dx equals 3 over 2 minus a half y. And the solution method for equations like this is to solve first of all the complementary function. That's the solution of the associated homogeneous differential equation. And we can write that down easily as y of x equals c e to the power minus a half x. Next we look for a particular integral. That's a particular value that satisfies the equation. So we look for a value yp equals a constant a, or 3 over 2 equals minus a half a equals 0, or a equals 3. Our general solution for equations of this kind is the sum of the complementary and the particular integral. So we have yg equals yc plus yp, that's equal to c e to the minus a half x plus the constant term 3. Now notice that we still have a constant of integration we'll need to eliminate here.